Hey, welcome back. So in the last video, I have showed you how to use your webcam on your computer uh, and MATLAB to take pictures of a specific thing and then save that picture over and over and over with a different name and then basically threshold that image using the image processing toolbox in the MATLAB section apps actually, and then how to save that also. So now let's go ahead and say that you want to crop your image, and basically your image is so for example this one, your image is big and you just want to have a specific section of your image, and then you want to work with that section. As I said, for this specific problem that I'm working, because I have to keep the keychain in front of the camera, the position of the keychain will change from one trial to another. So I'm not gonna really crop it really close. So I'm just gonna crop it like really far away. So I still have the keychain in the window. But for your specific project, you might have something a position in front of the camera, so it's not gonna move. So you can crop it better. So there is a function that is called um, uh, im crop, and that is for cropping an image, and it's like super useful. So I have already ran this program one more time, so all the figures and everything here, they are just all like open and they're all here. So what I'm gonna do is that I'm gonna type this command, and basically it's im crop my mRGB, which my mRGB is the last uh, modified RGB image that has been opened, meaning that it's my figure number 5. And then if you type this command im crop of whatever picture that you want to crop, and then give an I and some variable to it like I2 and reg here, and then if you run it, it will open you the last figure. As I said, is last figure, figure number 5, and then the cursor would look like this, and then you can open it to whatever size that you want. As I said, I'm not gonna make it small because I want to make sure that my keychain will always be there. And then have that, and then double click on it. Once you double click on it, here you will have your I2 and your reg. So let's say I want to see what is my I2. So I2 is basically all the pixel points inside that box that you have defined. So this is your box that you have defined. It has like 585 by 792 pixel points, and the other dimension 3 is because this is an RGB, so the R and G and the B. But the rec, if I type the rec in here, it's going to give you the rectangle or the box that you have defined. And if you keep these numbers and put in your program using the im crop, it will always crop your image using these numbers. And this is basically, let me see if I can show it to you. It's basically like these pixel points here, 46 and 31, and then these pixel points here, like 579 and 584. So it's basically those. So let's copy these pixel points and then come in here. So in here again, if you want to crop your image, you have to again read your image to crop it. So that's why we have to have like read the image section. I will copy and paste that section, but make sure that you're reading your thresholded image or your modified image, and just make sure that you give it a different name, not a name F again, because this is a different thing. And I'm gonna call this like RRGB, just some random name. And then after you have read your image, you have to crop your image, and that's where you will see that okay, now my new R reduced red, green, blue image is gonna be my im crop. And what do I want to crop? I want to crop my RRGB, which is basically this. Let me give it another name in here so you don't confuse. Yeah, so let's first read my image that I have saved in here and give this image a name. And then let's crop that image with what size? With this size. Oh, I have copied different things. Which size? Like this size. And let's crop it like this. And basically, we don't have like weird pixel points. They should be integers. So I'm just gonna delete these other significant numbers here, and then just gonna keep them like as integers. And yes, so what you do is that you're gonna say, let's crop the image that you have just read with this dimension and give it a name as crop RGB image. And now that I have cropped my image, now I can again do this entire thing, give it a name, and then save it. But again, make sure that you are giving it a different name, not this exact same name, because you don't want to re-save on your previous images. So just give it like number 3, some different names, and then make sure that you are saving the correct image, which is your RRGB. And then you have saved it. Now that you have basically before you so now basically you have read it, you have cropped it, but you have to open it again and then save it. So that's why here, after you have cropped it, you have to say open the image for me, and then once you have opened it, give it a name, and then save my CRGB. So let's read the previous image. Let's crop that. After you read that previous image, let's crop that previous image and give it a name. And then after you have cropped that image and gave it a name, let's show that image and then give it a name. I will give it another different name, like, to make sure that these are not exactly the same. So one more time. Sorry about all the repeating thing. Just want to make sure everything is fine. So let's read the previous image that you have saved and give it a name. And then let's crop that and give it a name. Let's show that and give it a different name. And after it is showed, let's save the showed image in this path. So let's save it and then run it one more time. Let's have my keychain here. Okay. So I will open the folder where they are all saved, and we see there it's not saved, and the reason is that I forgot to change this to 3. Yeah, we just have to really make sure that they are all okay, because we want to save this in this path, and then it was just resaving on it on the previous one. So now it should be fine. Let's do it one more time. Okay. And here's the folder path, and you can see it had so far saved the images, the modified image and the cropped image. So let's open two of them and put them side by side, the cropped and then the modified. Uh, you see how this one is smaller than this one, and that's because it's cropped. You can, as I said, you can just use it like really close and crop it, but you can definitely say this is smaller than this, and that is because it has been cropped. So you will crop the image, and once you have cropped the image, and then you have this figure, you will see that you will see this white background. And if you remember, I told you that a white color is 255, 255, and 255, and then you can use this data cursor to see the pixel point and its RGB value. So here this is the pixel point of 58, meaning 58 in the columns and then 55 in the rows here. So the X means column here and Y means row. And then this 255, 255, and 255 is the RGB value. But if you go to the black point, move your cursor to a black section, you will see they are all zeros, and it will show you at different pixel points. Like in here, this is really obvious. Like 247 is the column and 583 is the row. And then if you move it to a red one, you will see that you will see a combination of these numbers that are somewhere between 0 to 255. And that this combination basically was actually a red point. So just keep in mind so that you are having some white pixel points now because you have cropped your image, and it puts some white pixel points on the back. As I said, if your image is stationary and it's not moving and all these things, you can come here and actually read the starting pixel points that your actual image starts and the ending pixel point that your actual image starts, and then you have some idea that which pixel points are filled with your images. But for this specific one, because this will move every time I put my keychain in front of the camera, I cannot show you what I want to tell you actually right now. So right now what we want to do is that we want to count the number of pixel points that are black in this image and find a percentage of the pixel points that are black in this image. And because this image only has black and red, just ignore the white part. The black and red, you can find the percentage that is actually red if you subtract it. But if you want to find a percentage that is red without doing this, threshold of black, it's going to be really hard because you are having ton of different shades of red. You can see how the RGB values of them are so different. And it's really hard. You have to define so many different limits and ranges to say that, okay, if my R is in this range and my G is in this range and my B is in this range, this might be a red. But if you do it this way and making the background black, you are sure that this is just 0, 0, 0. So this is black. So let's count how many pixel points are black and then subtract it from the total pixel points, and I will know how many pixel points I had in red. Right? So that's why we did all these things. So now let's count the number of pixel points that are in black. What you need to do again is to read the latest file path that you have saved, meaning your cropped image. So you have to read that, and I will give it a variable name A. Full file name 3. So let's read the full file name 3, which was your cropped image. Let's read it and give a variable name to it. And because this is an image, it will read it like this. It's like an integer, it's like a UINT8, which means that it's a number that is below 255, meaning 2 to the power of 8 minus 1. So this is a matrix, but it's a matrix with numbers that are in that range. But if you want to really see it, you have to make it a double. And if you want to do that, you can say that, okay, all I have to do is to just make it a double. So that's this way you will have an integer for like a real number. The other way, this is for like images, but this way is for like numbers. So all I had done so far is to read my previous image, give it a variable, and make it like a number so I can compare it. And I did that, and now I will say, okay, my red is actually my S matrix, all the rows, all the columns, but the first dimension in the third dimension group. And my green is actually my S, it's all the rows, all the columns, and the second one. And also for the blue. So I will say my blue is all the rows, all the column, but the third dimension actually here. The third dimension of a third dimension. Something like that. The third section of the third dimension. So this way, I will have uh, some matrices that have actual numbers. Let's just run this part without going through the for loop. And what it does is that it will read the latest picture that you have saved and create an S for it. So let's just run this part. So I just want to show you what I mean. So you can see that your S is actually a double, which has 3 dimensions. But if you open your blue section, you will see like real numbers in terms of matrices. The 255 is the white frame on the side, and then you'll see all those like zeros, which are your black. And I don't know actually where my keychain is, where the number starts. It's hard to find it, but then this is the white on the side too. So now what I have done is that I read my crop image and I make it a double, so it's like numbers in matrices, and I have separate them into 3 different matrices, meaning the red matrix, the green, and the blue matrix. And all I have to do is to count the number of pixel points that all the 3 red, green, and blue are actually 0, meaning 0, 0, 0 RGB values. So that's what I type. I will say for I from 1 to the first size of my S matrix, because my S matrix, if you just type a size for it in here, it will show you that it has this size. It means this many columns, this many rows, and this many dimension on the third dimension. So I'm just saying from 1 to 755, and then I will type another for loop, and I'm saying from J from 1 to 1097. So basically I want to go everywhere in this matrix. I want to go everywhere in this matrix. I want to count how many pixel points are actually black. So I will say go pixel by pixel in this matrix, and if you see each one of these pixels to be exactly equal to 0, and all of them, I mean like all of them has to be 0, not just the red one. The red one and the green one and the blue one. So if all of them are 0, then we will count it. So before we go and count this, I have to define a matrix or a vector that is a 0 vector, meaning that all the elements of that vector is 0, and it has 5 rows and 1 column. Why? Because for each individual picture that you are saving, meaning we are saving 5 pictures here, I want to know how many pixel points are black, right? So I will define an empty variable that is all 0, and it has like 5 rows and 1 column, and each row corresponds to one of the images in here. And now that I have defined that n, and that n is 0, I will say that if you see a pixel that all these R and G and B values of it is 0, count that pixel and give one number to n. So basically add 1 to n, but not to which n? To the kth n. So if you are in the kth image, add that to that kth row of that n. Right? So at the end, I will have like 5 rows, and each rows correspond to a specific image and how many pixel points I have in that image. So basically, this is just counting, and then put an end to it. Okay? And then another end to it, because for this for loop, and then another end for the other for loop. And we have another end for the big for loop that everything is happening inside. After you have the number of n, sorry, you can divide the number of n to your matrix dimension, and you will get your percentage of black pixels. This is something if you want to do. To get the percentage of black pixel, you have to do the same thing here. Define a zero vector for your percentage of black pixel here too, and then you will say, okay, my percentage of black pixel, after like everything is done here, you're just completely finished. The percentage of my black pixels are my n divided by these two, meaning the total size of the matrix multiplied to 100. And that would be the percentage of black pixels. I will run this and you will see a weird percentage of black pixels, and then I'm going to explain to you why. Just keep in mind that I told you that my pictures and my keychains are not actually exactly in front of the camera, and I mean in the exact same position every time it can move. Just keep that in mind. Okay, let's do it. Okay, you'll see the percentage of black pixels are like 50%, but just looking at these figures, it doesn't look like 50%, it looks more than that. So this is the figure that is open through the crop, but once you read it one more time, it's going to be different. So this is the figure that you actually cropped your image, but once you read it, it's going to look different. So how is going to look different? Let's open another figure, and then let's call that image that you have read. This one in here. So compare this to the other one, like this one to this one. This is the cropped image that you have saved, but once you read it, it's gonna look like this. You can see there's like more white pixels around, and that's why this is 50%. So for the real project, for example, in my project where I have my tank with that dark water inside of it, it's always stationary in front of the camera. So what I did in my own project was that I came here and I read the pixel points that are actually my actual pictures, not the white background, and I put those pixel points in this part of the program as the size, instead of these sizes and instead of like this part. So I put a pixel point as an actual number, but I couldn't do it here for this problem because every time I put the keychain in front of the webcam, it might be in a different place, and it just might be different. So I didn't do it, and I didn't spend time to actually test it. So I just made it really simple. But the only thing that it will change is that you have to find the actual pixel points and then put them here instead of this simple size S1 and S2. That's the only thing that I can tell. But if you don't need to crop your image, and if you don't need to do all these things, if you don't need to basically crop your image, you actually don't need all this hassle. But if you need to crop your image, this is how you will do it. Or this is what I know you will do it. There might be a better way, but this is what I know, and I want to teach you. So I hope you guys enjoyed these two videos about like doing some simple image processing with MATLAB apps, and how to use your webcam and take pictures with MATLAB. So I just want to show you one thing, and that's what I actually did with this image process, because that was a simple keychain program. But I want to show you my actual data, and I'm just gonna open some random data, which I have no idea if it was working okay or not. Yeah, for example, this one. So I was not saving a ton of image because I was running the system for 24 hours every 20 seconds. It would have been a lot of data images. So I didn't save image 1, number 1, number 2, and number 3. I was just resaving on my images to only have 3 images at the end, because I was doing the analysis on the image right there when the image was showing, and I was sending signals to the pump right there. So I didn't do that. But this is how I use this method that I just showed you. I have this reactor, and this reactor is transparent and it's full with some dark liquid, which is wastewater here. What I did was that I covered the back side of my reactor with a red tape, and I covered in front of it with a red tape, and basically made a frame where the camera wanted to take a picture. And I had this like green tape here to show where I want the water level to stay around. And I used the same program that I just showed you, just some different things which were like defining a correct pixel points here, but other than that everything were the same. So I used that, and then I used that program. I created a function, and that function was actually coming to clean this picture. And you can see it cleaned this picture, but it's like here is still not nice. I have some things which I don't like I have these numbers, X and Y, which I don't like. So that's why I decided that I want to crop my image, and I might crop my image like this. And then in the program, I counted the number of black pixel points. And I know if I want my water level to stay around this line, which is the green line here, I need to have about 38 to 40% of black pixels. So that's why that from this, the number of black pixels that I could count using the image processing program, I told my LabView program, if you read the number of pixel points somewhere between 38 to 40, let the pump operate normally and add more feed to my reactor here. But if you read the number of pixel, the black pixel points here as like 50, 60% or above 40%, that means the water level is low. That means I'm having a lot of air. So here basically here is air and here is water, and if I see more black pixels, meaning that I have more air. So if you see like more than 40% of black pixel, let's send a signal to a pump and let's tell the pump to operate twice faster, for example. But if you don't see a lot of black pixel, like if you see a 35% black pixel, anything that is below 37, then that means the water level is high. That means that my feed pump already added a lot of feed to the reactor. So let's stop the feed. So that's how I use image processing in MATLAB and LabView and my serial communication box to send signals to my pump to communicate. so that I could keep my water level here consistently to a certain level. You might ask, why didn't I just purchase a water level sensor? That's because the sample that I had, the wastewater sample that I had in here, was not working with any water level sensor that I knew of. So that's why I decided image processing is the best, because I don't have to put anything into my bioreactor. My wastewater is not going to be in contact with anything that's going to ruin it. And then it's just picture is non-invasive. You might find image processing really useful. I know, like, my husband used image processing, and what he use image processing for is that he has this sensor that is measuring pressure, or actually not a number of particles in a room, like really fast. But for him to get the data out into Excel, he had to pay some extra $1,000 to purchase a software for it, so that the software could send the data, meaning the number of pixels, out to a computer. And he didn't want to spend that much money on it, so he only had the instrument. And on the LCD of the instrument, his numbers were showing every second or 2 seconds. So he used image processing, and with a camera, that the camera takes a picture of the LCD of that instrument and analyze that picture, and then it can find what is the number. So it's not as easy as this one that I showed you. It's a little bit more complicated. So it can analyze it, and it can say, okay, so what I'm reading is 120, and then put that 120 into a vector, and then at the end he had all the data saved. So he's with using a simple camera that he paid for like $50, like I paid the camera for $50 too. And with a simple, like not simple, but some MATLAB programming, you can save yourself and your advisor a lot of money. And it's really useful, and you will feel great once you use it. So in the next video, I will show you how we can put this program inside LabView and then use it. So the only thing you have to do is to build a LabView program, open the LabView program, and then run it. And in the background of the LabView program, MATLAB will run also. Till next video. Bye.